Vara Virtual Academy, we are back. You have to believe that. Problem number 9, proficiency SAT ACT. Trent walked from John's house 3 miles due north, then 4 miles due east, while John walked 6 miles due south and 8 miles due west. If John were to walk directly to Trent's location, how many hours would it take him if John walks at the rate of 3 miles per hour? Alright, now first thing to start with here is to remember that north is on the top usually for our maps, right? Maybe Australians have a different opinion on this. South is down, you have west on the left and east on the right. Now the point is this one, you can switch them in whichever way you want, okay? Make sure, I mean, you can switch north with south, east with west, as long as you're using the same for both, you know, Trent and John's moves, you will be fine. Okay, good. Let's put John's house in the middle here. Okay, this is John's house. How about that? Okay, what it says. Trent walked from John's house 3 miles due north. Okay, so we have John that is going 3 miles north, and I should probably use a different color here. 3 miles due north. Okay, and then what else? 4 miles due east. So I have Trent, which is going 3 miles, right? And then is going 6. Then 4 miles due east. Okay, 4 miles east, and this is 4 miles, and that's where my friend Trent is, right? John walked 6 miles, and I suppose he walks from the same house. 6 miles due south. Okay, and this is John goes south about 6 miles. I mean, you should approximate this one to your best, it really doesn't matter. And 8 miles due west. 8 miles due west. That's about that. 8 miles. This is where John is, right? Now, those guys are crazy, right? What's happening with them? They're playing hide and seek or what? Or tag, maybe. Kind of crazy tag playing, right? So many miles away. If John were to walk directly to Trent's location, how many hours would it take him if John walks at the rate of 3 miles per hour? Okay, so John's speed is 3 miles per hour. We need that at the end. But before that, we need to find, okay, what is the distance? How far away is John from Trent's location, right? We need to find how big is that line. How can we find it? Alright? Well, there are many ways, okay? Maybe some of you have already figured it out. I mean, this is not so complicated. You guys can see that if you draw a line here from Trent down and parallel to the line north-south, right? And then you draw a line that will extend John's, you know, west travel to the west. Those two lines will intersect, and more than that, because this angle here is 90 and this angle here is also 90, I can tell you that the angle of the intersection of the two lines, right, the one that drops from Trent's location and the one that extends John's last trip, that was pretty much southwest bound, right, will intersect at a 90-degree angles. And more than that, I know this distance is, right, I know the distance from Trent to the point of intersection of the two lines, which is what? 3 plus 6, that's going to be 9 miles. And I also know the other side of my right triangle, the right triangle that I'm getting with the distance from John to Trent and the two lines, they're intersecting at a 90-degree angles, the one that's west-east and the other one north-south, right? How big is that line? Well, this one here is 4 miles because we have a rectangle, as you can see. And 4 miles plus 8, this is going to be 12 miles, right? And I have what? 9, 12. And if you guys remember one of the previous lessons when we talk about Pythagorean triples, I said 3, 4, 5. If you cut 3 pieces of wood, right? And each one has a length of, 3, 4, and 5. If you put them together, you're going to get a right triangle where 5 is the hypotenuse, 3 and 4 are shortest distances. And if you multiply each one of them by the same number, let's say if I'm multiplying each one of them by 3, okay? 3 gets multiplied to everyone. I'm getting what? 3 times 3, 3 times 4, and 3 times 5. And this is also Pythagorean triple, which tells me what? That the first one squared plus the second one squared will give me the last one squared, right? Well, we have the same situation here because 3 times 3 is 9, 3 times 4 is 12. I can tell you right away that this distance John to Trent is going to be 15 miles. If you don't believe me, just apply Pythagoras' theorem, which says the sum of the square of the shorter legs, the shorter sides, equal the square of the longer side, which we call hypotenuse, right? So 8 squared 64 plus 9 squared 81 should give me 225. And check out if not, 81 plus 64, that's 225. So I was right. Okay, if not, like I said, take step by step and see how long is that hypotenuse John to Trent distance, which is 15 miles. Are you done? Well, you're not done because the question of the problem is not how far away are them from each other. It may be prone, and you're going to be wrong to say 15E as the right answer, because the question is, for the problem, if John were to walk directly to Trent's location, how many hours would it take him if John walks at the rate of 3 miles per hour? And to find how many hours John covers in at this rate of speed, you have to divide distance by speed, right? And your distance we found is 15 miles. Your speed, and you can even use the units just to see that this is going to help in your physical sciences classes or in chemistry, right? When you have to work with units, over what? 3 miles per hour, okay? When you divide, you have to do what? When you divide, you flip multiply. You skip 15 miles and you multiply by the reciprocal of the other one, which is what? 1 hour per 3 miles. And now 3 miles, miles and miles will cancel out. 3 goes in 15 5 times. 5 times 1 hour is going to be 5 hours. Okay? And that's why the answer to this problem is B, 5. How many hours? 5. 5 hours John will be able to reach Trent's location if he goes 3 miles per hour. Okay, that's pretty much the average walking speed. And this is one way in which you can solve a similar problem on the proficiency or the SAT. And I hope you guys understood. I hope you guys got it. This is it for tomorrow's class. We'll do more in the class. Thank you.